So today we are looking at different functions in order to determine whether or not they are odd or even, or increasing or decreasing. And if we look at these problems here, we're not going to do all of these. We're not going to have perfect graphs. We just want an idea of what these graphs would look like, just in case we happen to have a multiple choice question, something like that. So let's take a look at a few of these and we'll talk our way through these. If you look at problem number 1, notice that these are in descending order, and notice that for problem number 1, the highest exponent is 3. Well, 3 is an odd number, so I know that this is an odd function. And remember, if it's an odd function, the tails actually go in different directions. And not only is it odd, if I look at the coefficient, I have a 1 here. And since 1 is positive, I know that it's also a positive function. So it's odd and positive. So what would it look like if I wanted to describe it? Well, I'm just going to describe it using words. I'm sorry, just using tails, basically. So it's odd and it's positive. Well, if it's positive, that means it starts low and ends high. Something like this. I really don't know what's going on in the middle. I could plot a few points, right? For example, I could let x be 0, and that would make y 7. So I know that the point 0, 7 is somewhere on the graph, but we're not really worrying about that today. Today we're worrying about the basic shape of the graph. So the graph would start low and it would end up high. So it's low on the left side, high on the right side, and it's odd. Let's look at problem number 2. Problem number 2, the highest power is 3, so that makes it odd. And since it has a positive 1 in the front, it is an increasing function. So this one is also odd and positive. So it's going to be low on the left side, and it's going to be high on the right tail. And again, I have no idea what this graph looks like in between. I have no idea how many times it hits the x-axis. I do know that the y-intercept is 0, 4. Because if x is 0, y is equal to 4. But again, we're not worrying too much about that. We just want to talk about the end behavior. If you look at problem number 3, the highest exponent, is that odd or even? Well, since it's 3 and 3 is odd, I know that this is also an odd function. And again, the leading coefficient is positive 1. So it's also increasing. So it's positive. So it's going to start low, and it is going to end up high. So it's going to be low on the left side. It's going to be high on the right side. So you would word it something like that. If you look at problem number 4, this one's a quadratic. The highest exponent is 2, so it's an even function. So we would say it's even. And again, notice that the leading coefficient happens to be positive 1, so it's positive. And remember, if a function is positive, the tails go in the same direction. And in this case, since it's even and positive, if it's even, the tails go in the same direction. And since it's positive, it's going to be up on the left, and it's going to be up on the right side. And again, we really don't know a whole lot about what's going on here. If you look at number 5, this is going to be an odd function because the highest power is an odd number, 5. And it's also increasing because it has a positive 1 in the front. So since it's positive, it's going to start low and it's going to end high because it's an odd function. Notice the tails go in opposite directions. What about number 6? If you look at number 6, the highest power is 2, which makes it an even function. And this time, the leading coefficient is negative. We have an understood negative 1 here, right? So this is going to be tails in the same direction. So it's going to be down, down, right? Notice the tails are down and down. That's what the end would look like. So this is an even function that happens to also be a negative function. Let me erase that and try to do a better job for you. Let's see. So even and negative. Okay, looking at problem number 7. Notice that the highest exponent is even, so it's an even function, and the leading coefficient is a positive 2. So I know it's going to be up on the left and up on the right. So it's up, up. Remember, if it's an even function, the tails go in the same direction. If it's positive, it's up, up. If we had had a negative 2 or another negative number as the leading coefficient, then the tails would be pointing in the same direction, but both down. If you look at problem number 8, this is going to be an even function, positive leading coefficient again, so it will also be up on the left and up on the right. All right, so that takes care of identifying a function as being odd or even, and then describing its end behavior. I want to go back and clear all of these off, and I want to talk about maybe coming up with a more accurate graph by using the y-intercepts. So let's look at number 2. We said that 2 is a cubic, and we said that it's positive, which means it's increasing. It starts low, and it ends high. Let me try again. Let's do the x-axis here and the y-axis here. And we said that if x is 0, this term goes away and this term goes away, and that leaves me a 4. If x is 0, y is 4. So I know the y-intercept is 4, which means the point 0, 4 is on the graph. So let's see. We know it has to start low and end high, and it has to pass through here. So it's going to look something like this, maybe, right? It's going to have to go through there like that. So that gives us a little more information about the graph. I could factor it to figure out the exact x-intercepts or zeros, but again, that's not the topic for today. Thank you.